Welcome to the third exercise in the Alibre practice parts. Let's start on this one by sketching on the XY plane. And I'll open my line tool. And as before, start from the origin and take care to add as many automatic constraints as I can to make quick work of this sketch. I'm going to sketch out the basic profile of the part that I want to make. And I'm not going to take too much care to try to be exact because we're going to dimension this to the exact size. And now that I have the basic shape constructed, I'll grab my vertical and make sure that this line is vertical as well as this one. I think everything else looks pretty good. Grab a dimension, and we'll make this have a radius of 8, and then we'll make this have a height of 32. And then we'll worry about the radius here of 16. And we'll give this line a height of 30. And then we'll give this line a height of 6. And we'll give it a radius of 14. We'll give this a radius of 50 and a height of 14. Then we'll give this one a radius of 18 and another height of 6. Then we'll give this a radius of 20. And we'll give it a height of 40. And then we'll give this a height of 6. And we'll also give it a radius of 6. Then we'll give this a radius of 7.5. And a height of 30. Very good. So this is fully defined. Now, these dimensions, this is a dimension method known as chain dimensioning, where I dimension from one point to the next point, and then from that point to the next point, and then from that point to the next point, and so on. Chain dimensioning was used here so that this could be very readable and easy to follow along with. But if you're actually going to manufacture the part, it may be worth noting that if this dimension were to have a tolerance of, say, plus or minus 1, and then we go to this having a tolerance of plus or minus 1, and then the next one has a tolerance of plus or minus 1, then if this is plus 1, and this is plus 1, and this is plus 1, then you have a stack up of tolerances that will be plus or minus 3 when you get to some edges, because every single edge can grow or shrink by, in our arbitrary case, 1. So another way of dimensioning that is harder to follow along with in the video is to all go from one point to the next. And that way, by having all of my dimensions be referenced off of the end, all of the plus or minus 1s can be not relative to one another, right? We break the chain by referencing the same edge in all of our tolerances. So that is something to keep in mind in the future for design intent. But of course, that would be harder to follow along with, so we stuck with chain dimensioning here. We'll deactivate the sketch. We'll run a revolve. We'll go with an axis here. And we started to make our shaft. Let's grab this top plane view, or top plane sketch rather, on this top edge and make a rectangle. Give this a dimension of 12. And we'll grab an equal dimension to turn it into a square. And then I like to use the symmetric constraint, where I grab a line of symmetry and then 2 points for them to be symmetric around the line. Grab my origin and we'll go to 42. Next, we'll deactivate the sketch. We'll run an extruded cut, and I would recommend going through all. Next, we'll want to add some holes on this face. And we want to set this up so that we'll be really successful if any changes come about. So one way of doing this is to grab our plane, and we'll set a distance of 20 millimeters because that is the radius of that face. And that looks about right, so we have our plane right there. And now I can select my plane and choose my hole feature. And in my hole feature, I have some specific dimensions that I would like. Let's go with a counterbore. And we'll go 11.91 millimeters here. We'll go 3.58 here. We'll say 8 in this box and 5.79. And now we'll go to this little option to insert hole, and I click right there. Let's add a vertical relation to make sure that we are vertical with our origin. And then we can establish a height, and I'll do that actually from this bottom edge. We're going to say 59. So we were able to establish our hole. The next thing is we'll want to add a chamfer on our edge. And we'll give this 2 millimeters. And I'll change this to angle distance, and we're at 45 degrees. So with this chamfer added, the last thing that we want to do is run a pattern. So we'll close this, circular pattern, and I would care about patterning my hole and my extrusion here. We have 4 instances. We'll change it to this instance pattern, and we'll select a center. How about the center of this face? And there we have all of our features patterned in 4. So I've got my completed part here. Let's run a few tests on our design intent. Maybe I would intend in the future to update this part so that this would have a distance of 30 instead of 20. If I deactivate my sketch, generate to the last feature, my holes in this surface are gone. So if I run to inspect and I create a precise section view and I cut my part open to see why my holes are missing, we can see that the holes have been generated as more of a cavity in this part than holes. But we want holes and holes on this face. So we need to update our design intent to make sure that that's possible. If I go to my plane 3 and edit it, we've defined this plane by being parallel to my XY plane and 20 millimeters off, and that's where we get the 20 millimeters off of that plane. So what I can instead do is click on this to say that we want it parallel to our XY plane and not 20 millimeters, but rather tangent to whatever this face is. I'll click the reverse here and say OK. Next, if I go to my model and generate to the last feature, we can see that our holes are back. And now because we have that plane being tangent to the face, the part will update automatically no matter how we dimension this face right here. So that should be very helpful in being able to update the face any way that we wish. And just to prove it out, I'll take my 30 here and change it back to 20, the original dimension. We'll deactivate the sketch and generate to our last feature, and the holes show up without any problem. Next, we talked about chain dimensioning. I have a number of the same dimensions here. So we have a distance of 6 right here, and I have another distance of 6 and another distance of 6 right here. So maybe it would be my intent that if I update 1 6, I want to update every 6 to the new dimension. Maybe I'm trying to fit a standard bearing size in there and I want to adjust bearing sizes. So instead of using a dimension every time, I could set these lines to be equal with one another, and then I update one dimension and all of them will update at the same time. So that would simplify the number of dimensions to make it easier to look at, and also it can update our intent so that it's easier to adjust should we need to make adjustments in the future. So that is some thoughts on making this part and design intent. I hope it was helpful. Thank you for watching, and I'll see you in the next exercise.